all that stuff in the beginning, whether something's positive or negative, then so much the better, all right? So C, 6 over 1, invert it, change the multiplication. D, we already know how to do a negative mixed number. Negative divided by negative is a positive. E is a good problem. Go ahead and solve E. What do you get for E? Go ahead and do E. Again, I'm going to pause the video. Help me remember, guys, if you can. All right, so you said your answer is a fraction. Remember, if it would have been an improper fraction, we would change this one to a mixed number. Somebody tell me why. Why would this one go, Gabe? Because the original was mixed numbers. Remember, if it's half and half, I'll take it either way. But when both are mixed numbers to begin with, then your answer would be a mixed number if the answer is a mixed number. And this one's not, right? Class, the answer is negative 33/35, right? Again, be careful with the negative mixed numbers. That's minus the quantity 4 times 5 plus 2. That's a negative 22/5. Don't make that mistake of thinking it's negative 20 and a positive 2. Again, it is not. So one more time, your numerator would be like that. Okay, that's a negative 22. Okay, go ahead and do F. Again, I'm going to pause. Are you ready? Positive or negative? Negative divided by positive is definitely a negative. On 3, 1, 2, 3. Ooh, not so strong, huh? A little bit of concern there. Would you agree we invert the divisor and multiply? Do you agree? There's the divisor. Invert it and multiply, right? Remember, this is simply a shortcut for multiplying the top and bottom by the reciprocal, making the bottom a 1. That's what the rule is. That's where the division rule comes from. So again, we can R-bum here. So what is this? Negative 1/2? How many got negative 1/2? Okay. All right. Because again, our top, remember the top, when everything's gone on the top, it's always a 1, because anything divided by itself is a 1. We don't usually have to worry about the 1s, because if there's another number up there, you're multiplying a 1 times it, it's just the number. But when everything's gone on the top, everything's not really gone. It's a 1 up there. All right, let's continue on. All right, now to the nitty-gritty of adding. All right, and this is where you really need to be careful. How do you add fractions? Add the numerator and put it over the common denominator. And again, we're doing plus or minus at the same time. Add the numerators, put them over the common denominator. That should be your thoughts. That should be in your brain. That's what your brain should say. You look and say, oh, I'm adding fractions. I need to add the numerators and put them over the common denominator. That's not a lot. Right, so far, what have we done with fractions? Top times top, bottom times bottom. Let's R-bum. Division. Invert. And then do what I just said. Top times top, bottom times bottom, R-bum. Okay, that wasn't a whole lot. Now we're adding. Add the numerators, put them over common denominator. Biddy, 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 biddy. That's all, folks. That's it. All fractions boil down to those things. That's it. That's all. So get over your fractional phobia. All right? It doesn't need to be there, shouldn't be there. All right, now again, adding fractions can be a little bit more involved because sometimes you have to get to a common denominator, right? So there's a little bit of work involved with that, but you should at least know what you need to do. Okay, couple easy problems. Go ahead and do A and B. Again, I'm going to pause here. All right, so again, if I showed the rule step, that would be the rule step. 7 negatives and 4 positives is 3 negatives. And this one, if I showed the rule step, 9 negatives and 3 positives, 6 negatives. Did you leave your answer like that? Shame, shame if you did. Always look to reduce. 2 times 3, 2 times 5. The 2's are gone. Negative 3/5. How many were 2 for 2? Awesome. And again, if not, notice what's getting you. Notice your mistakes. Hey, I forgot to reduce. Okay, put that in your memory bank and say, next time I'm going to remember to reduce. All right, go ahead and do C and D. C and D, I'm going to pause. Unfortunately, they get zapped by the light sometimes. Okay, so the top one, add the numerators and put them over the common denominator. And everybody says negative uno, right? And the second one, add the numerators and put them over the common denominator. And everybody says negative a half, right?
Yes, sir.
How many were 2 for 2 on those two? Beautiful for spacious guys. All right, I am recording. Good, I didn't forget. All right, do E and F. Keep it going now. E and F. 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 There's a fountain flowing. E and F. Huh? Oh, I didn't pause. All right, E is obviously -1. And of course, F, you did the minus thing, right? And said that's a plus. So surely you said 6/14. I hope. And therefore you ended up with 3/7, right? How many had 3/7? All right, that one got a few of you. Huh? Be careful. Nothing hard there, though. Nothing hard. Nothing hard. All right, even G, for time's sake, I'm going to pass up on it because we've done a few mixed numbers. That's going to be, what, a 25/4 minus 5/4. You're going to end up being a 20/4, and the answer is going to be 4. A lot of 4 there. Nick. Si, senor. No, -1.
But there's no mixed numbers.
Nick, you're not thinking. How old are you? Would I ever say Nick is 13/1? I would never say Nick is 13/1. Again, you know, that's the thing's 1. Make it a 1. That would be like, that would say like if you came to -15/1, you're going to leave it that way. Well, no, it's -15, right? Just further simplify that special case, Nick. Yes, sir, Sam? Isn't G5? What did I say? I did it back. Yeah, it's 5. No Kool-Aid for Sam. Awesome, man. All right. Okay, so where do you have to be careful is when you're adding and subtracting, you don't have a common denominator, but your brain says, hey, add the numerators, put them over the common denominator, and then you say, oh no, I do not have a common denominator. What will I do? I will fret and worry. I will say I hate these fractions. Why do we have to do this stuff? These things always drive me crazy. I can never get these right. What in the world? Of course not. You say, I'll get a common denominator. So, what would you do algebra-wise on this to get a common denominator? Who can tell me what to do? Jack? So you got to tell me what to multiply by. That's what I'm asking. That's my question. What do you want me to multiply by? Well, you got to tell me what number, what. Tell me what to multiply. That's the question. All right, stop talking. Raise your hand. Who can tell me what to do to be able to do the rule? Nick? But you got to tell me what. What are you talking about? Tell me what to multiply by. What? 2. What do you want me to do? You got to explain to me what you want me to do. Stop talking. All right? You got your shot. You don't know. Austin. Like that? All right. See that? Now, that was an answer. That's not quite correct, but that was an answer. Okay, so that's what I'm looking for when I want you to tell me what to do. Ileana? Yeah, and you know what? Let me show it to you. Remember, we need the LCD of the denominators. And I really need the bottom here to have a y. Why? Because the other fraction has a y on the bottom. And therefore, I'm going to multiply it by a y. Whatever I do to the bottom, I'm going to do the same thing to the top. Now, the second one, I need to have an x. So on the bottom, I'm going to multiply it by an x. Now they both have an xy. Austin, you were so close. You just had to switch them. And whatever you do to the bottom, do the same thing to the top. And now I have a common denominator. And now I will add the numerators. Take my red for my plus minus. Dx over, and I'll use my blue for my x and my green for my y, my common denominator of xy. That's with letters. But really, we're going to deal with numbers, and we can do all that with numbers. So remember, the best common denominator is the LCD, which is the LCM of the denominators. We know how to do this. So refresher with an easy number, or easy numbers. Is 48 a common denominator? Yes or no? A common denominator. Is 48 a common denominator? Yes. Is 36 a common denominator? Yes. Is 24 a common denominator? Now, a lot of students, that's what they do. They just do the 6 times 4 is 24, and I'll use 24. And by the way, you can always do that. That's not always the easiest way to do it, but you can always do that. Multiplying the two bottoms will always give you a common denominator. It may not be the least or lowest common denominator, but it'll always give you a common denominator. However, when you do that, you'll always have to reduce when you're done, always, guaranteed. If you use the lowest common denominator, least common denominator, maybe you'll have to reduce, maybe not. So let me refresh your memory how to find the LCD. You factor the 6 into a 2 times 3, right? Do you remember this? And you factor the 4 into a 2 times 2. And do you remember that? Can anybody now tell me, raise your hand and tell me what the LCD is in factored form, Kirsten? Yeah. Nope. 2 times. Okay, so 2 times 2 times 3 is the LCD. If you remember, every column gets represented once. Okay, so really our LCD is 12, not 24, though 24 is a common denominator. Now look, this is as easy as this is. All you got to do is look at the 6. What is the 6 missing? It's missing a 2. So I got to multiply the bottom by 2? Whatever I do to the bottom, do the same thing to the top. What is the 4 missing? The 4 is missing the 3. Whatever I do to the bottom, do the same thing to the top. Okay, where am I at? The top left is a 3. I got a plus sign. The top right is a 9. All over the common denominator of 12. Okay, a 2. Thank you, Jack. No Kool-Aid for you. 2 times 1 is 2. The left is a 2. 3 times 3 is 9. The right is a 9. 2 plus 9 over 12. Final answer, 11/12, right? Now again, you can just multiply 6 times 4 and use that. But when the numbers get bigger, that method will give you trouble. This is an easy one. In this one, the LCD is the 4 times the 3, right? So you multiply the left by 3 over 3, the right by 4 over 4. All right, why don't you try C? And I'm going to pause. Go ahead and try C. Fine, reduced. What'd you use as your LCD? Say it. 70 is the LCD, lowest common denominator. A 35 is a 5 times 7, and a 14 is a 2 times 7, making 2 times 5 times 7. What is the first one missing? The 2. Multiply it by 2 over 2. What's the second one missing? The 5. Multiply it by 5 over 5. That gives you a negative 6 minus 15 over 70. 6 negatives and 15 more negatives, 21 negatives. 21 over 70 does reduce every once in a while. Even though you use the LCD, it will reduce. How many got negative 3/10? Awesome. For you and the rest, what happened? What happened? What? You didn't have enough time. All right. Sometimes, again, reviewing, you won't have enough time because time is of the essence. Let's skip D. Let's do E. Dewey. Dewey Decimal System. Let's do E. Dewey. Dewey, Dewey. Gotta pause. Are you ready? All right, so I showed the steps there. Finish it off. 88, 98, 108, 118. I'm frozen. Unfreeze. Now I got to count all over again. 88. Remember how to add positive and negative numbers quickly. Start at the low one, count to the high one, use the sign of the high one. 88, 98, 108, 118. So that's a negative 35 over 24. The bottom is 3s and 2s, and the top is 5 and 7. Does not reduce. However, we had mixed numbers to begin with. So minor deduction here. Negative 1 and 11/24. How many got that correct? Very good then. Good job. Bravo Zulu for you. Again, I generally on something like this, maybe half a point off or something if you didn't change it to the mixed number. But again, mixed numbers to begin with, so we'll finish with that. How many got at least a negative 35 over 24 or the answer? Okay. And again, the rest of you, I don't know where you went astray. 8 and 3 means do the 3 and do the 8 because they have no factors in common. And that's what the LCD does for you. It takes into account the common factors. You don't need those. You do what they don't have. And there you go. Any questions on adding, subtracting, multiplying, or dividing fractions? Those are the kinds of problems you will see on Wednesday, and the ones that you'll have to do and perform in the concepts of adding fractions. Any other questions? All right, let's review some scientific notation. Remember, scientific notation is to write very large numbers or very small numbers. And by the way, let me remind you at this point, folks, when you write a number more than 1,000, include the commas. It is the height of arrogance on your part. Very arrogant thing to write your number without the commas. It shows that you are arrogant. That's what it shows. Because you have no, and you're inconsiderate of other people. You have no consideration of the person that has to read your number. I will make that person count all my zeros to make sure it's the number that he thinks it is. Because who can tell by just looking? You can't. The only way you know is if the right amount of zeros are there. Very arrogant thing, very inconsiderate thing. Which is the reason why I always take points off when you don't put your commas in on numbers like that. All right, do you remember how to change that into a scientific notation? Go ahead and do that. Put that in scientific notation, proper scientific notation. Question, Jack? The video is playing right now. All right, if you are done, say your answer on 3. 1, 2, 3. Okay, I heard some of the correct answer. 1.23 times 10 to the 3, 6, 9, 12, 13th. 1.23 times 10 to the 13th is the answer. Let me remind you, you will do all digits and any zeros in between those digits. You will always put the decimal point after the first number. The beginning of any scientific notation number is always a digit from 1 to 9. Okay? You will then use the X for the times. This is the only time we still use an X for multiplication. Every other time we use a raised dot, but it is a standard in scientific notation to use an X. Then we have to figure out the power for the 10, and you simply count how many times the decimal point moved. It started here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. Therefore, the exponent is 13. 1.23 times 10 to the 13th. Jordan.
I thought we were trying to say
I'm not sure what you were thinking on that. That's never anything that I ever said. Okay, that's something you've gotten in your brain from somewhere else. Okay, the number can be gigantic. The power of 10 could be, over 100 if you need to. Now your calculator will only calculate up to 99. Maybe that's something of what you're thinking in your brain. But it is what it is. Power of 10 is however many places the decimal point moves. All right, go ahead and do number 2. All right, be careful with these. Is your exponent positive or negative? Remember, when the number is smaller than 1, the exponent's always negative. So hopefully you have 6.7 times 10. And again, that's where my decimal point ended up, right? So I know it's going to be negative. 1, 2, 3, 4, 5, 6. I can count, and it's a 7. How many got that right? Okay. All right, good. Almost everybody, if not everybody. Very, very good. Okay, try 3. Just give you a moment for that. Negative 7 times 10 to the negative 9, right? Again, the number is negative, so keep a negative. You would, listen now. Everybody look up at the screen for a moment. Quite honestly, you cannot do that. You can't put a .0 there. You might say that's numerically correct. Numerically, the value may be the same, but as I've told you before, precision-wise, it is a different answer. That would be if there were a 0 on the end, which shows the number precise to that decimal place. Because the number was not precise to that decimal place, we do not put a .0 there. But again, if it would have been precise to that decimal place, we would have put the .0. Okay? If it would have been 2 O's on the end, we'd have put .00, again to show the accuracy of the measurement. All right? That's a small technicality, but if you're going to be excellent, that's the way it needs to go. All right, let's write the other way. Go ahead and do 1 and 2. Put them into normal notation. Don't do 3 yet. All right, so you look at number 1. Because of the negative exponent, hopefully you went this way. 1, 2, 3, 4, right? So it's 0.0005 or 0.0005. Some people just understand there's 1 less zeros in front and do 0.0005, 3 zeros in front for a negative 4. If that were a negative 7, it'd be 6 zeros in front. If that was a negative 10, it'd be 9 zeros in front between the decimal point and the first number. All right, and then the other one, some people look at this and say, hey, 6 is million. 7 is 10 million. Right? But again, if that's not the way you operate, that's fine. You got to have enough zeros. I just put a bunch of them out there and move it 7 places. 1, 2, 3, 4, 5, 6, 7. Okay, it's right there. I don't need those. Remember to always rewrite your number. Always putting in the comma. Whoa. What did I just do? 1, 2, 3, 4, 5, 6, 7. What did I do? Oh, 6 is 100,000. Stupido. See, that's why you got to be careful with shortcuts. Because when you do a shortcut, you have to remember the shortcut right. 6 is a million. 7 is, wait a minute. I still don't like it. Do I? Yeah, I had it right the first time. Okay. Yeah, just doing my things. Doing my commas. That was my problem. It's great until I did my commas. All right. 90,200,000. Yeah. 6 is a million. 7 is 10 million. 8 is 100 million, 9 is a billion, etc., etc., etc. But again, just count. How many got both of those right? Okay, and that's what I hoped. All right, last one of scientific notation. Can you add those? Again, you don't have a calculator in part 1. See what you can do with that. I'll give you just a moment, and then we'll go on. I'm going to pause the video. What do you have to do so you can add them, Gabe? Nope. Well, that's the long way. Look, you can get away with that on a small one like that, but if I gave you that, now you're in trouble. Okay? So your methodology only works on easy ones. And again, I always teach you to learn how you can solve everything. So what do you got to do? What do you got to do, Alex? You got to make the exponents the same. Which one do we change? The big one or the small one? The small one. If I take that from a 3 and make it a 4, what do I do to the number? I just made the exponent bigger. I make the number smaller. There you go. And now all you're doing is adding up the front part. 3.64 times 10 to the 4th. Okay. How many got that correct? Now, again, I will say for small numbers, if all else failed, you can go Gabe's method on small numbers. But again, that won't solve everything. Sam. It is right now because the front number is a 3. However, if the front number, if it would have been 36.4 times, let's say, 10 to the 7th, I need the front, it always has to be a digit of 1 through 9 in the front. So then this would have to get smaller, and that would have to get bigger if it were a situation like that. Or if I ended up with like this, 0.364 times 10 to, let's say, the 11th, and let's use even negatives. If this has to get bigger, then this has to get smaller. But this already has a single digit in front. It isn't proper scientific notation. Good question, though. Nick? You sure?
The directions say to write it.
Oh, that was... Yeah, I didn't mean to do that. I meant to have a separate section. But that's okay. Doesn't matter. Yeah, if you'd have written it out then, it would be what? 36,400 is the number. All right. Part 2. Part 2. Let's get started here because there's a lot to go in part 2. As I tell you in part 2, a big thing of part 2 is equations, because a big thing of pre-algebra is to learn how to solve equations. I will tell you this, remind me on Tuesday I need to add a few equations that I forgot to put into the review. So just remind me at the end of equations, put those couple more in. I forgot to add square root equations and equations with the variable squared, because we did those this year. Okay, so if you remember basic equations, A shouldn't be trouble at all. Go ahead and do A, and then hold off on B. Students usually stumble on doing B. Now, you know what? As a matter of fact, let's just, somebody raise your hand and tell me what to do on A. Raquel, what do you want me to do?
We have to add
So tell me what to add to both sides. -3 gets added to both sides. And now we end up with 4x equals 16. And what do I do next? What's next, Lauren?
divide both sides by 4.
Right, this one we can do the shortcut. We'll divide both sides by 4. And we end up with x equals 4. Pretty simplistic. But look at B. Students tend to stumble on B. I want you to try to do B here in the next minute or two. I'm going to pause the video. This is an important one. Students tend to miss it, even though it's really an easy one. Things multiply times the variable. You move by multiplying by the reciprocal, right? I mean, that's all you need to do on this thing. Very simple problem. Positive divided by a negative is a, and our negatives go in the top, right? Not in the bottom. -2/21. How many got that correct? Okay, oh, good. Awesome. Very good. Students tend to forget all of a sudden when they get to that all by itself. Hey, we know how to do that. Multiply by the reciprocal. Piece of cake. Away we go. All right, we'll pick up here on Tuesday.